Hey everyone, if you've ever thought about getting into solar for a camper van or maybe an off-grid cabin, you know that getting the panels wired up can feel, well, a little daunting. Today, we're going to pull back the curtain and make this whole process super clear.
So it really all boils down to this one huge question. Do you wire your panels in series or in parallel? And trust me, this isn't a small decision. As you can see here, getting this wrong can absolutely tank the performance of your entire system. So let's make sure that doesn't happen.
Okay, first things first. Before we even think about touching a wire, we have to answer the most important question of all. How much power do you actually need, right? You can't design the system if you don't know the goal.
Now, luckily, the starting point here is surprisingly simple. A fantastic rule of thumb is to just figure out how many amp hours you pull from your batteries every day and multiply that number by 2. So, if your setup uses around 150 amp hours, you're going to want to aim for a 300-watt solar array to get those batteries topped off reliably.
All right, now that we have our wattage goal, we can get into the fun stuff. Let's dig into the 2 basic ways you can connect your solar panels together to build your array.
So on one side, you've got series wiring. The easiest way to picture this is like a daisy chain, You connect the positive of one panel to the next and so on. The key takeaway here is this. In series, the voltage goes up, but the amps stay the same. Then you have parallel. This is where you connect all the positives together and all the negatives together. And here, the exact opposite happens. The amperage adds up, but the voltage stays the same.
To make this super clear, we're going to stick with one simple example through this whole explainer. Let's pretend we've got 4 identical 180-watt panels to work with. And check out how the math works. It's pretty cool. Take a look at that series row. We've got 4 19-volt panels. 4 times 19, boom, 76 volts. But the amperage stays at a steady 9.5 amps. Now, look at the parallel row. The voltage doesn't change, it's still 19 volts, but the amperage stacks up. 4 times 9.5 gives us 38 amps. And notice, either way, volts times amps gives you the exact same total power, 720 watts.
So, if the total power is identical, how in the world do you choose? Well, this is where theory meets reality. The math is only half the story. Now we have to talk trade-offs.
Okay, the biggest one, and I mean the biggest one, is shade. With a series setup, if just one of your panels gets a little bit of shade from, say, a tree branch, it acts like a clog in a hose. It chokes the power output of the entire string of panels. It's pretty much all or nothing. But in parallel, each panel is its own little power plant. If one gets shaded, the others just keep on working at full blast. Next, let's talk about money and hassle. Series wiring, it's just simpler and cheaper. Because the amperage is low, you can get away with using thinner, much less expensive wire. Parallel, on the other hand, can get pricey pretty fast. That high amperage, 38 amps in our example, that's a lot of juice. It needs some seriously thick, heavy, and expensive copper wire to handle it safely. Plus, you need extra gear like special connectors or a combiner box. And we absolutely have to talk about safety. That high voltage in a series system, 76 volts in our case, is a real shock hazard. You really have to be careful with anything over 60 volts DC. On the flip side, parallel systems run at a much lower, safer voltage. But, and this is a big but, because the amps are so high, you must have a fuse on each and every panel's positive line. That's non-negotiable. It stops a bad panel from causing a really dangerous situation. So, we've got pros and cons for both. You might be leaning one way or the other. But here's the kicker. The final decision isn't really up to you. It all comes down to the brains of your solar system, the charge controller. Think of your charge controller as the gatekeeper between your panels and your batteries, and it has some very strict rules. For example, this controller here needs at least 25 volts just to wake up in the morning. It absolutely cannot handle more than 60 volts coming in, and the most current it can take is 40 amps. Whatever array we design, it has to live inside this window.
So let's check our work. How do our arrays stack up? Well, our series array is putting out 76 volts. That's way over the 60-volt max. You'd probably fry the controller, so that's a definite fail. Okay, what about our parallel array? It's at 19 volts. That's actually too low. It's less than the 25-volt minimum the controller needs to even turn on. So that's a fail too. We're stuck.
And this happens all the time when you're designing a system. You're caught in the middle. Your voltage is either way too high or way too low. So what on earth are you supposed to do?
This is where the magic happens. The answer is so elegant, you don't have to choose. You can actually use both methods at the same time to create what's called a hybrid or a series parallel array. It really is the best of both worlds. It sounds way more complicated than it is. Check it out. All you do is take 2 of your panels and wire them in series. That gives you 1 string at 38 volts and 9.5 amps. Then you just do the exact same thing with your other 2 panels. So now you have 2 identical strings. The final step? You just connect those 2 strings together in parallel. That's it.
And would you look at that? When we connect our 2 38-volt strings in parallel, the voltage stays at 38 volts, but the amps from each string add up. 9.5 plus 9.5 gives us 19 amps. So now we have an array that's putting out 38 volts and 19 amps, and that fits perfectly inside our controller's window of 25 to 60 volts and under 40 amps. It's a perfect match.
This hybrid setup is just fantastic. First, and most obviously, it lets us dial in our voltage and amps to perfectly match our controller. But it also gives us better shade tolerance than a pure series array. And because the voltage is a bit higher than a pure parallel array, it starts making power earlier in the morning and keeps working later in the evening. You get more power throughout the day. So let's boil it all down. Here's your checklist. Number 1, always start with your wattage goal. Number 2, know the basic math. Series adds volts, parallel adds amps. 3, think about the real-world trade-offs, like shade and cost. And number 4, the golden rule. Your final design has to play nice with your charge controller specs.
See? Solar wiring isn't about finding the one right answer. It's like having a set of Legos. You learn the rules of how they connect, and then you can build anything you want. You create the perfect custom solution for your project. So now that you know the rules of the game, what are you going to go out and power?